So I have to go back to my problem and take a look at how I would figure out how to minimize what's going on here. So when I talk about minimizing my cost, that means I have to talk about the cost that's associated with what's going on. When I look in the problem, the things that talk about cost in here are the $15 an hour for the machine and the $10 an hour for the student. So the machine, remember that was the X thing, and the student, that was the Y thing. And a little bit earlier in our class, we talked about $1 for a piece of chalk, $5 for an eraser. What combination would give me, you know, this many of this and this many of that? We're going to do the same thing now by writing a cost equation. Okay, so $15 an hour for every machine and $10 an hour for every student. If I go back to my diagram now, what I'm going to write down is that my cost equation, or in other words, the cost equals $15 per hour for every machine and $10 an hour for every student. This is my cost equation. In order to figure out how to minimize this cost, I'm going to look at the three vertices of the green region. So I'm going to write down the ordered pairs and figure out the cost. Let's go to the first and maybe easiest coordinate. Look at the top right corner of our green shaded triangle. What are the coordinates for that point right there? 8, 8. So I know that this coordinate is 8, 8. That's one of the points I'm going to check. Oh, look at this. If I look at the bottom right-hand corner of the green triangle, I can find the coordinates for that point as well, because I already know what the x coordinate is. What's the x coordinate? 8, because it's on the blue line. In order to figure out the y coordinate, all I would have to do is take that 8, that is the x value, go to the pink line, plug it in for the x value, and find the y. You try that right now. So I know it's 8 on the pink line as well as the blue. You're going to plug it in for the pink x in our equation, find the y value. Okay, so we find out that when we plug in the 8 on the far bottom right-hand side of that triangle, which also intersects the pink line, I would have 11.6 minus 1.2 times 8, or in other words, 11.6 minus 9.6, and that's how we got the 2. In the last vertex, what do I know about the last vertex? 8 is the y value. And I know that that 8, that's the y value, is crossing the pink line as well. So if I put in the 8 where the y value is and solve it, I'm going to tell you that you would get 3. So write that down for now. You can go check that later. It's just about solving a simple equation. You can do that on your own later. So these are my 3 vertices. Why are these important? Because the minimization of my cost will occur at one of the vertices of the feasible region. You should write that down. The minimal cost will occur at one of the vertices of your feasible region. I will write that at the top. The minimum cost will occur at one of the vertices of the feasible region. It could happen at any of them. Generally, it's only one that actually is the lowest, but there have been times when 2 or more could have the same exact low cost. Rare. Can happen. With those 3 points, I'm going to plug in each of those values. So I'm going to go to another screen so you can kind of see this in a cleaner method. Maybe I have some space down here. No. All right, well, I'll just make it work. Here we go. So our cost, if you remember in the purple, was equal to 15x plus 10y. Let's look at what happens when we plug in the first coordinate. The first coordinate being the very first one that we found, which was 8, 8. So if I look at the point 8, 8, that tells me that I'm going to have 15 times the x value, which is 8, plus 10 times the y value, which is also 8. And so 15 times 8 is 120, 120, and 80 is 200. What this is saying is, in order to produce things that way, it would cost me $200. The second coordinate that we talked about was 8, 2. That's the one that Adil told me that it was 2. And so in this case, I would have $15 per hour for the machines, and the machines would have been spending 8 hours plus $10 per hour, and that was for the students, and that was for 2 hours. So I have 120 there plus another 20, so that's $140 if I use my machines and students that way. And the last way that I could do this is if I looked at the one that was 3, 8. So 3 hours for the machines and 8 hours for the students. So that would be $15 an hour for 3 hours of the machine time and $10 an hour for 8 hours of the student time. And that would be 45 and 80 for a cost of 100. Did I say 45?
Yeah.
125? $125. And out of these 3 options, which one is the best? 3, 8 if you're trying to minimize your costs. So what you say then is x will be 3 and y will be 8 in order to minimize my cost, which turns out to be $125. This is the new thing for today that we didn't talk about yesterday, is that there'll be some kind of cost kind of equation. You will find the vertices in the feasible region, and you'll plug each one of them. There could be 3, there could be 5. You plug each one in, find the minimum or the maximum or something like that. That's the extra thing today.